So let's transfer over to start talking about the client APIs and SDKs. And really what we're talking about is building apps. Whether you're a web app developer or a native app developer, or perhaps you're doing both, it's all about accessing the functionality of ArcGIS using our client APIs. And there's a couple of patterns that we promote. You can, of course, use the APIs and the SDKs to dig down and get full control, not just of the ArcGIS functionality, but full control of the devices that you're running with. Or you can use configurable apps, and that's all about making you more productive. What we really want to do is focus in on the APIs and the SDKs. And first of all, we're going to talk about the web APIs. Now, this is a really big year if you're a developer, and we're launching the JavaScript 4.0 API. It's been in development for quite some time, and the way that we refer to it is it's the JavaScript API reimagined. We've taken a lot of the ideas that we've learned over the years, thought hard about it, redesigned the API to make it consistent across the entire surface, to make it very consistent if you're a 2D map developer or you're a 3D scene developer. We're making it easier for you to integrate it in with other JavaScript frameworks as well. And also, we've been working on making it mobile first. What does that mean? It means the design of the widgets work great on mobile devices as well as the traditional desktop browsers. So what I'd like to do now is pass over to Yann Cabon from the JavaScript development team, and he's got a series of demos to take us through the new 4.0 API. Yann.
Thank you, Euan. So while you were developing with the 3x API for the last 2 years, we have been building the 4.0 API that is already powering the web scene viewer. And I want to go through a couple of, well, a couple actually, 17 tabs of examples showing new features and new coding patterns that this API introduces. So first, this is a very simple map, just with a graphic. It's one of, could be one of our samples. And to produce that map, I've created a graphic first, actually, with a point, geometry, and a simple marker symbol. Here, what I want to show you is that you don't need to remember what is the order of the parameters to create the instances. You don't have to remember that. You just pass an object with everything in it, as well as, you know, the order here also, but as well as we know that the outline of a simple marker symbol is a simple line symbol. So we do the work for you to actually create the instance internally. What it means is that you have way less modules to import and makes your code much more simple. Now I've created my map with a National Geographic-based map, and one of the big changes also in 4 is the introduction of map view and scene view as in the Quartz Ontime APIs. The map view is sorry. The map is actually the model of all your layers, and then the map view is what actually draws the map on the screen. So you create a map view with a map and a container, the properties like center and zoom, and then I pass just my graphic. And here my graphic is also automatically converted inside the map view. So if I have one map view for one map, I can also create, for example, a map with multiple map views. So in that case, I see the contiguous USA, and then I have 2 extra map views for Hawaii and Alaska. And actually, they are interactive, so I can pan around. And to achieve this, I've created once my map with my base map and my dynamic layer, as well as my first view with a specific center and scale. And I've created 2 extra views, one with the Alaska and one for Hawaii, where I changed the center and scale as well as the rotation to fit better into my little space. So all of these big changes, you can discover them through the brand new SDK. It has been redesigned both as designed, but also on the content. All the content is brand new. You have new guides, new API reference that is quick searchable, normally. And then brand new samples code. So I invite you to discover it when we release the API. So the map view is one thing, but we also introduced the scene view. So I have the exact same map as before, but now I have created a scene view. So the scene view works the same way. You create a map, you create it with a map and its container, as well as now the camera. The scene view understands extent, center, scale, but camera is really what drives under the hood the scene view. And then I've created, I pass also my graphic. So 3D can be challenging in terms of navigation. It's also challenging in 2D when you get a bunch of features coming from a query you just performed. You have to compute what is the extent and everything. So we introduced in 4 a new method called goTo to be able to quickly go quickly where you want to go. So in that case, I just want to rotate my view when I click on those buttons to rotate around this mountain, or I want to change the tilt of my camera. So I just have to get the current heading of the camera, change the heading, and just call goTo, and then all the work is done for me under the hood. 3D also has some interesting capabilities like environment. The environment defines the lights and shadows of your scene view, and you can also define the time of the day. So based on the time of the day and the day of the year, you can see basically the stars and also the sun position. So here we are in Brest, where I come from in France, and we have the castle of Brest at the bottom, but then when I change the time of the day, it also rotates the star. Well, rotates the Earth, right? The scene view can be the scene view can also display local and projected data. It's great if you want to have this fishbowl type of experience. This is a scene view that has like projected data with elevation and also features. I can define the clipping area like Russ showed previously to just clip what I want to see, and then after I can easily like tilt my view to access the features that are underground. In this case, these are earthquakes, and then when I click on them, I can have the pop-up. In 4, we have made some concepts that are already in the API, new classes for them to make easier to work with them as developers. So like the new base map class. So to define this base map of the Arctic Ocean using the new Arctic Ocean services, I created a new base map with a thumbnail URL so that my base map toggle here can pick it with the base layer. So this is the bottom, and then the reference layer. To assign this base map on the map, I just assign it directly. The map understands well-known base maps, like it's like in 3x, like topo and streets, for example, but you can also assign new instances like this. A great way also to organize your visualization is to create group layers. Groups layers together, and then you can also define the visibility of each individual layers inside it, and define how the behavior changes. So if I toggle a layer here, the other ones are toggled off. But I can change the behavior to have independent layer visibility. To create that first group layer, for example, I created a group layer here with its title for my TOC to catch it, and then visibility mode exclusive, meaning that only one layer in that group can be visible at once, and then a suite of layers. One of the capabilities that we already have in 2D is to display raster images and perform analysis client-side. The image layer fetches data in a binary format and actually goes through it and draw every pixel. And you can define that function that draws the pixels and choose the color for it. But it can also filter out data. So in this case, I'm visualizing sea temperature. And then if I change if I move my slider, I can filter out the temperature I'm not interested about. And this is all redrawn client-side. So there is no extra request to perform those changes. It's pretty awesome. We introduce also the new ArcGIS elevation layer that allows us to display elevation client-side, but we can also like perform very fast analysis, like a line of sight. So if I just click here, let's say, and then I drag my cursor, I have a line of sight of what I can see, right? I can go also like do a profile, for example. This is not the most accurate profile, but it gives a very great user experience. What is great with the JavaScript API is also to be able to get your features down to the web browser and also style them directly on the browser, so to create very appealing visualization. This one shows trees, and the trees are sized, the marker that represents the trees are sized with the size of the canopy of the tree, and then the color is changed based on its capacity of storing carbon. So to define this, I've created my simple marker symbol, and I want to create a renderer with a visual variable. So the first one is a size info, where I size the size of the tree based on its width, and also the color based on the carbon storage. I've defined my min and max value, and as well as the two colors. And I create my renderer that I assign to the feature layer. What works in 2D works also now in 3D. So the main benefit of 3D here is that I can take advantage of the extra dimension to size, for example, the trunk, as well as the canopy, and the canopy can be sized in height and width and depth. So I've created my point symbol 3D with a sphere, and then this is for the canopy, and then I've changed its height, width, and depth. And then the color info, as in 2D, same exact values. And I've created my simple renderer for my tree layer here. And finally, if I want some more realistic look, I can use directly 3D models of trees. And this is using a simple unique value renderer with different unique value infos, one per tree species. And based on this, the tree will be sized as well as, well, the tree will be changing based on these species and sized based on the exact same attribute as before. So with the web scene viewer, you can author web scenes, but with the brand new Portal API, you can bring those web scenes down to the client and actually work with them. So here I have designed a little app where I showcase the different slides of a web scene. So if I toggle through them, it changes the layer visibility, go to a different viewpoint, and then it's pretty nice to convey the information. And to do this, this is the new pattern that we introduced, the two new classes, the web map and web scene. And the web scene you created with a Portal item ID. And then when the scene is loaded, I can access its slides, and for each slide, create a little image. And when I click on it, this is all I have to do to change everything. Just call slide, apply to the view, and it will go to the animate to the appropriate camera, change the time of the day, change the visibility of the layers. But so we have the web scene, but we have also the new web map class. The new web map class will much better than in 3x, where you can create a web map with an ID and now access its layer as it loads, and much better to work with it. So here I have a very simple web map where I store the bookmark of New York. I will go to New York. And then one of the brand new capability of the API is to be able to bring down to the client individual layers that I've saved as items in my organization. And all I have to do, so this is a beer versus wine layer that has been designed by Jeremy Bartley. And I just copy and paste this ID, and then I will just add it and show you the code. Right, so I've created my web map. And this is how I bring down a layer. I would just call layer from portal item. I pass down the item ID. I could also set the URL of my portal if it's not ArcGIS Online. And then when it's added, I can just add it to my map. And what is great here is that it brings down the renderer as well as the actual pop-up. And all of this has been done for me previously on ArcGIS Online. And now Rene Rubalcava will introduce us what the API can do to build great apps. Thanks.
Thanks, Yann. So first off, the pop-up experience has been completely revamped for 4.0. For example, if you try and open a pop-up near the edge of the map, it's going to go ahead and reposition itself so that it's always going to stay inside of the map area. That way it's consistent throughout. You can also dock the pop-up now. This way you can dock the pop-up to a location and still interact with your map without the pop-up being in the way. And the pop-up's also designed to be responsive. So if I were to change this map here from being landscape to portrait, it's going to go ahead and reposition itself to the bottom, which is the best location in this case. We've also added some enhancements to the pop-up so you can kind of enhance the pop-up with custom actions. So if I click on this tree data here, in the pop-up I have an extra button down here called tree photos. So the way you get that is you just define an action for your pop-up template, and then when you click on that button, you just do something with it. And in this case, what I would do is do a Flickr search for the tree types of the data that I clicked on. This is another more extensive application where I'm going to be using a custom actions on the pop-ups when I click on a river, a section of the river. And when I do this, I have a custom action that's going to calculate the nearby flow and put in a little tooltip in the custom pop-up based on the stream gauges that are nearby. So this one's pretty kind of cool. You can also use the geometry engine to add some real-time geometry analysis to your application experience. So in this case, I would imagine I'll drop a bottle in the middle of the ocean. And when I do this, I'm going to go to a geoprocessing service that's going to calculate the route that bottle will travel using our ocean current data. And then on the client side, I'm going to animate the route, but in real time, I'm going to create a buffer around that route and then select the tide stations that fall within the buffer. So this is a really cool use of using the geometry engine to increase your application experience. We've also introduced enhanced widget experience for you. So the widgets have been completely redesigned, and that way they're a lot easier to use and style on your own. And one of the things that we've done is introduce what's called a UI container. So the UI container is really neat because it will help you have a consistent widget layout so that your widgets are always going to be positioned correctly. And what I've done here is I've highlighted the UI container area on the map. And when you create a map view, you can just tell it what the default components are that you want to have. And they'll all be positioned in some default location. And then you can also add additional widgets. And when you do add your widgets, you just add them to the UI and tell them that you want them in a particular position. And the application is going to go ahead and maintain the position of those widgets throughout its entire use. So that's a really good use to be able to have a consistent layout for your app. And one of the other things that we've done is made the widgets themselves a lot easier to style. So I took the same application I just showed you, and I've gone ahead and restyled it so that it kind of matches the data of my map. And you can do that by just updating, let me open the pop-up too, updating a few CSS styles. So you can, we've provided CSS class names that are pretty consistent, and they make it really easy for you to be able to style your entire application around your map. You can even take that a step further, and you could take your custom styled vector tiles and completely revamp the UI with enhanced UI experience, so you could theme your whole application to your vector tiles. So in this case, we're going to go Lakers, right? So you can completely brand your entire application. Another part of the widget story is the introduction of the view models. So the view models are really cool because they're the workhorse behind all of the widgets in the API, and they have all the business logic available for you. So you can integrate them with other frameworks and completely create new UI experiences. So this is an example here is the zoom view model. And the zoom view model is pretty simple. It has a couple of methods, zoom in and zoom out. And what you can do, we're going to help you out here by providing the source code for all the widgets in the API. So if you go to like the zoom widget here, and you click on zoom.js, we're going to give you the source code for the widgets that we're building so you can see how we're using the view models, and you can use that as a guide to build your own widgets to completely redefine the application. This sample here, what I've done is I just went ahead and I'm using a framework called React to create a completely new widgets over here on the left-hand side. And it's pretty simple to do. I just integrate the view models with my React components like I normally would, and I'm able to just compose them together and build a brand new widget experience. So you could use a use case for that is if you want to build, say, your application to be mobile-based, and you want to focus on having mobile-friendly widgets, so I want my zoom and my compass to be more thumbpad friendly, you could do that as well. And it's pretty easy to do because you just create your components the way you would with your framework of choice, and then you can even add those components to the UI container so that the layout's going to be consistent throughout. Something else we've introduced this past year has been some build and optimization tools to help you out a little bit more. So you can still use the CDN for development purposes, and you can use the web optimizer. But we released the API as a Bower repo not too long ago, and by using that repo, you can do custom builds of your entire application. The Bower repo is also going to contain the source SAS files that we use for the CSS in the API, so that you can go ahead and you can update those SAS files on your own, integrate them into your current build workflow, and you have full control to do custom local builds of the API and your application. And with the right tooling, you can get down to having a single JavaScript file and a single CSS file. So with all the API enhancements and the widget experience, the ability to integrate with other frameworks and the custom build tools, there's no excuse for you to not build great apps. Thank you.
Now, this is the 11th Developer Summit. How many Developer Summits have you been to?
9.
9. How many as an Esri employee?
This is my first.
This is his first one. So last year, he was sitting out there in the audience looking at all of our work, and this year, he's actually showing you all of his work. It's pretty cool. Thanks, Rene.
Thank you.
So when are you going to get your hands on the final build of the JavaScript 4.0 API? The team's in beta at the moment, and they'll be releasing final in Q2 before the user conference this summer. And then throughout the year, you'll see more releases of 4.0, 4.1, 4.2, et cetera, where they'll be adding more renderers, more layer types into the API. And what about the 3x JavaScript API? We just last week released the latest version, and we'll be having a couple more releases this year, but it's fair to say that most of our development effort is being spent on the 4.0 API, and you'll start to see the releases sort of ramp down. However, there's a very important note there. Any of your applications that are built with 3x will continue to have full technical support until 2018. OK, so that was web development. Now we want to change gears a little bit and start talking about native app development. So why native if we've got all this great technology with our web APIs? The most common reason often is you want your applications to work connected as well as disconnected from ArcGIS platform. Or you maybe want to exploit the capabilities on the device. So you're using a native API that comes with the platform and integrating our work in with it. Or maybe you want to connect to some of the sensors that you can connect onto these native devices. And of course, if it's native, you get the best performance available on that device. So that's the reasons why you picked native technology. What we're doing to support you as native developers is building a runtime. We refer to it as the ArcGIS runtime. The majority of it's written in C++, so we get the great performance that you would expect. Although we expose it to you using a native API, iOS, Objective-C, Java on Android, C# on .NET and Windows platforms. And we have a common conceptual model that covers all of the different APIs. So if you move from API to API or platform to platform, there's a common functional set that you can rely on. With Quartz, which is our latest release, we're releasing a significant set of functionality for you as developers. Many of you are building ArcGIS Engine applications today waiting on this functionality so that you can start to transition to the runtime. We really feel that the Quartz release of runtime will enable you to make that transition. So there's a lot of new capabilities with new APIs, support for content coming from the cloud or locally stored on your devices, support for analysis being performed locally on the device or through geoprocessing services, 3D coming across the entire platform of the runtime supported devices, and a number of ways to make it easier for you to build cross-platform native applications. So I've said the Quartz API is a significant step forward. We've, just like the JavaScript team, reimagined the API that we're building. And we've taken a step back and really focused on making it a productive API for you as developers so you can get to the code, get to the end solution as quickly as possible. Significant enhancements in mapping, working with web maps that Justin showed earlier on this morning. Seamless integration with the platform so you can work with identity, named user model, or not. And all of the runtime APIs reflect this new structure. So what I'd like to do now is pass over to Will, and he's got a demonstration showing us the new runtime API at Quartz. Will.
Thanks, Euan. So Quartz introduces a host of new, improved APIs for you as runtime developers to build better apps. And the most important API that we've been working on is the mapping API. And that puts the map at the heart of the runtime. So here in Android Studio, I'm working with a map object. And you can see that a map has a bunch of properties, has operational layers. And I can easily edit my map by adding new layers to that operational layer array. It also has a base map object. This is a new object that you can instantiate from a portal item, or as a developer, you can build your own. So you can add reference layers, which sit over the top, or you can add base layers, which slot underneath. So you can start to build up really powerful applications. Now this map object here, you can see I instantiated from a portal and a portal item. So it represents a web map, the same web map that Justin presented earlier, the web map spec. But this map object also supports a new map type called a mobile map or an offline map. And that's the same spec as a web map with just a couple of additional properties that allow you to save the layers and the data locally. So what I want to do now is move over to my iPad and show you an example application that's built with mobile maps and shows you some of the workflows that you've been telling us that you need. And this is peer-to-peer or device-to-device map sharing workflows. So here I have an application that's built for me as a first responder. I can sign in using my ArcGIS named user and access my portal, and it gives me all the access to the maps. But what I want to do is author a new map that allows me to respond to a particular event that's happening right now. It's slotted in a new base map. This is the night style vector tile base map from Esri. And I can go ahead and start to add layers that my colleagues have shared with me. Somebody's gone out and retrieved some data from the open data site from DC and then aggregated it with some incidents that I need to go and respond to as a first responder. And I can add that layer, or that layer from a feature layer to my map, and it's added in a bunch of feature layers that are styled accordingly. What you can see on this map is that the symbols are styled by attribute. So this is the same way that smart mapping styles attributes. The size of the points are sized by a unique value renderer, so I can see the type of incident, but they're also sized by the number of people that have been affected by that incident. So as a first responder, I can zoom in and see areas that I really should go and attend to. Now, I'm taking this app out into the field, so it wouldn't be a demo from me unless I took a map offline. But what you're seeing here is actually a new part of the API that we're building. This is something called the offline map task, and it does all of the heavy lifting of taking a map offline for you. It looks at the layer types in your map. It works out what type of task in the runtime it needs to create for that layer. It synchronizes all the results of those different layers, and then it saves the map to disk with the data in a format that I can open up. So now I've got my map on my device. I can take it out to the field. But actually, when I'm out in the field, I meet a colleague of mine who actually needs to use the same map. And he's got an app on another device. He's got another runtime app. And he wants exactly the same map, but we haven't got an internet connection to be able to share this map or the data. So what I'm going to do now is I'm going to share this map. Now, when the offline map task worked, it took the map offline and saved it on disk in the same format as a mobile map package, an unpacked mobile map package. So now, as a developer, I can zip up that map and share it with my colleague. So I'm going to try and do this via AirDrop, and you can see that it's connected to my Mac. So I switch over to my Mac, and you can see that I'm going to share it. And look at that, that's worked. Not too many of you are sharing at the moment with AirDrop. And then on my Mac, it dropped into my downloads folder, and I've got another application here where I can get hold of that mobile map package and drop it in, and it's opened up exactly the same map. And that's quite cool. That's a peer-to-peer or device-to-device sharing workflow. So let's have a look at the code. So here I am in Xcode. This is Swift. I create a new map object, and I create a base map with a base layer that's of type vector tiled layer. And here's the instantiation of the vector tiled layer with a URL to a portal item. I can then see where I add the layers from the portal feature service that I had. There's a constructor here, a helper method on AGS layer, which creates a list of layers from the portal item. And then I can add those layers to my operational layers array. And then when we look at the code for taking the map offline, I create an ArcGIS offline map task, pass in the map, which I want to take offline. And then I call take map offline. I pass in the polygon area that I want to take offline and some parameters and save it to a path. And that's what creates the mobile map package on disk. And then if we look at the code for the OS X app, you can see that I create a mobile map package here with a path to where it is on disk. And then I access the maps inside that mobile map package. And I simply just assign that to the map and then view that. So that really shows how we're improving working with mobile maps and offline maps. Now what I want to do is move over to my iPad again to show you how we're improving mobile map package support going forward and talk about some of the new layer types and new things that you can put inside them. So here's an application I've built. This is completely offline, so I'm going to go into airplane mode. And what you're seeing here is actually the vector tiled layer for the entire world on this device. Okay, this vector tiled layer is 11 gigabytes, and it's living on this device. And the vector tiled layer is perfect for me because all I need to do is visualize the results. I don't need any of the GIS data to do identifying or routing. What I also have on this device is a locator for the entire world. This is the same locator that you can see in ArcGIS Online. It's got all of the POIs, the place names, and the addresses that you can see in ArcGIS Online. And I can now work with this offline on an iPad. And this shows how we're improving locators moving forward so they're low memory and really fast so they can run on iPads. So let's have a look. Let's prove this to you. So I can go to an address quite close to us. You can see the vector tiled layer is rendered correctly. I can go to the Naval Museum of Madrid, again, around the world. And because this locator supports multiple languages, I can also use Cyrillic characters to zoom to Moscow. And there we have Moscow. And because it's got the whole world, I can, pick a random location, see where my finger finishes up, and do a reverse geocode, and it gives me something that I can't pronounce. So that's how you have it.
Hey, Will, that's great demo so far. It was really, really neat stuff. And these next couple of addresses that you were going to geocode, well, since you've been practicing them all week, we kind of know they're going to work. But we actually thought it might be a little more fun to try a couple of random addresses. And I collected a few during the break. So how about we try this one? Talking with Tony, and I got his address of 250 Brook Drive.
I can spell that one. That's OK.
I think, yeah, I hope you can spell this one. In Reading, of your home country in the UK.
I spelled that one correctly, too.
Yeah. Can you find it, Will?
Bang on.
Ooh, that's really disappointing.
Come on,
the first one worked.
Something harder.
Can we try one more? I didn't even get any with any umlauts or anything in it, so it's kind of disappointing. But here's one more: 2979.
Yeah.
140 Street.
140 Street.
Yep.
Is that a street? Yes.
In Surrey, Surrey, British Columbia.
Well, I'll try that and see where that finds. That could find something in the UK. Look at that.
Oh,
I'm actually quite impressed.
Was really, really disappointing.
Nice.
I was expecting at least one of them.
No failures here, Justin.
So
no failures
never mind.
Here. Go on, back in your box. Anyway, thanks, Justin. Well, you helped me. So yeah, no smoke and mirrors in that demo at all. Thanks, Justin, for showing us how we're improving mobile map packages and working with mobile maps going forward. Back to you, Ian.
It's just as well that worked. OK. All right, let's move on to cross-platform development. And we want to focus in on the Xamarin SDK. There was a very exciting announcement from Microsoft just last week with their purchase of the Xamarin company that creates the Xamarin technology, which shows that we're right in line with Microsoft's direction for Visual Studio. We're going to be enhancing our .NET SDK with Xamarin support. And it's important to realize that when you are using Xamarin to build an application for iOS or Android, the API surface that you see is exactly the same as the API surface that you would see as a .NET developer. So if you've got .NET applications today written using our .NET API, you'll be able to move these to iOS and Android with relative ease using the Xamarin SDK technology. And I'm really excited to welcome Morten Nielsen on the stage, and he's going to show us the Xamarin SDK in action. Morten.
Thanks, Euan. So you've already seen that the Runtime SDK actually runs on quite a lot of different platforms. And a lot of you guys are using C# or Visual Basic against the Runtime SDK for .NET to build your apps. So I'd like to show you a little app we built here. This app is an app that runs on any Windows 10 device. In this case, I'm running on Windows 10 mobile emulator. And if you've ever been to the Esri campus, all the buildings look kind of the same, and all the hallways they look the same too. It can be quite hard to find your way around and find the right conference room and be there on time. So we built a little app to try and help with that. For instance, here I have a runtime offline geocoder that allows me, for instance, to find where the receptionist is. Maybe this is where I arrive, and I might have to go to the usability lab. Now, we'll go ahead and use the offline route calculation and give me the shortest walk time to the lab. And it was raining yesterday. You probably saw some of the Southern Californian people. They don't really like the rain very much. So this also gives you an alternative route that tries to favor walking inside as much as possible so you don't get so wet. So that's the little dash line you see. Now, this is actually a really useful app. But with bring your own device policies, and most companies have today, the employer doesn't get to control what kind of device that your employers have. Or in this case, maybe the guest visiting and using this app. Let's be honest, most of my coworkers, they're actually using Android and iPhones. Not a whole lot have a Windows phone. And that's a problem for me, because I'm a C# developer. That's where I'm effective. I can really crank out some code in C#. But now I have to learn Java and Objective-C on Swift, and then build the app 2 more times. And that's just not a very good use of my existing skill set. So this is where Xamarin comes in. With Xamarin, I can use C# to write against iOS and Android's native APIs, as well as most of the .NET APIs. And we took the source code for the .NET SDK for runtime, and we recompiled it for Xamarin, so you actually get the exact same API surface for Xamarin as well. And it allows you to share even more of your code across all these different platforms. So let's take a look at what this looks like. Now, over here, I have my Visual Studio solution. And you'll see up here I have my shared project. This is where all my shared code is, my shared data, my geocoder, my helper for calculating routes, my view models, my assets, and so on. And below here, I have my project heads for Android and iOS and Windows. And this is where I put code for specific to the layout or for platform-specific things I want to take advantage of the individual platforms. For instance, here you'll see my Android app. It looks a little more like an Android app. That's the designer here. I can switch into the Android's layout XML, where it's all defined. For those of you who already build Android apps, this will look very familiar to you. However, let's switch to some of my shared code and set a breakpoint. I'm just going to launch this on my Android emulator. And there we go. Same app. Let's go to, for instance, from the auditorium to maybe this conference room. And just like that, I have a breakpoint inside Visual Studio, the tool that I know. So think about that. This is an Android app running on an Android operating system, but built in C# inside Visual Studio and debugged inside Visual Studio, where I can really be effective. I think that's super powerful, and as Euan mentioned, Microsoft just announced that they're going to acquire Xamarin, so that kind of integration, I can only hope will actually grow a lot more over time. But what about iPhone, right? You already probably saw it, so it's probably no surprise. Maybe if we can get the iPhone up. There we go. That, of course, it also runs on an iPhone. I already entered the address here, but the same app runs on here just as well. And this app, after I had built it for Windows, it really took under a day to bring into Android and iOS. It was very little work. Most of all my hard code to figure out how to deal with get the data collected and calculate routes is the same. I did have to spend a little more time on learning like the different layout systems of these platforms, but we will also be shipping support for Xamarin Forms, which allows you to also share your view code and actually use XAML to define these views and share even more. Really excited about this. We'll have a tech preview for everyone to download end of this month, and it will go final with the .NET SDK later this year. Thanks.
Great. Thanks, Morten.
Thank you.
Now that you finally have that app on an iPhone, I think I'll be getting a copy of that. OK, 3D. 3D is always best seen rather than talked about, so I think we're going to go straight across to Adrien, and he's going to show us what the team's been working on in 3D runtime. Adrien.
Thank you, Euan. Last year on this stage, I was announcing 3D coming to the ArcGIS Runtime SDK for .NET. Since then, we released 10.2.6, 10.2.7 with 3D capabilities, and also ArcGIS Earth built on top of this SDK. So I'm going to show you once again how easy it is today for .NET developer to move their native 2D application to 3D. For this, I'm going to go back to the application that Morten was showing you earlier. It is a really cool app, but it does have a slight issue. What happens when you're going to go from the first floor to the third floor? Well, that route is actually correct, but visually, it's not passing the right information to the user. Sometimes you do need that extra dimension. What a coincidence, I'm the 3D guy. So I'm going to stop that application, and exactly like last year, something that developer can do today, I'm just going to change in Morten's code the map view to be a scene view, the map to be a scene, and there's also a view model, so I'm going to do the same changes there. If Visual Studio wants to open the page, thank you. And I'm going to just map to be a scene, and I think there's one more here, the map to be a scene. And I'm going to run that application, no more changes. I just changed variable types and not their name, so hopefully no developer is watching right now. So the application is now running in 3D. I haven't done any other changes, and it already look and feel like 3D. Just because my features were already Z-enabled, so displaying them on a scene allows them to take their real place in space. The routing was also Z-enabled already. So if I go from my third floor this time to the first floor, well, this route actually makes sense now. If it's not raining, I'll take the outdoor stairs. And if it is raining, I'll probably want to go to the indoor stairs. By the way, if you're used to 10.2.6, you'll be happy that at 10.2.7, we modify our navigation to be able to select fixture even up in the air as anchor point for your navigation, making it really easy to navigate around your scene. But the runtime is part of the ArcGIS platform, so I have access to all that 3D content that the platform is giving me. So I spend a little bit more time on this application to try to make it more 3D beautiful looking. So here you have a 3D model of our campus. I can actually disable the buildings to see the interiors and just play the routes that I just defined earlier. So that's what you can do today using the ArcGIS Runtime.NET SDK. Now, I'm going to talk about what's coming next. We have been saying that at Quartz, our internal re-architecture allows us to share all the functionality with all the APIs, no more favorites. Well, 3D is one of them. That means that 3D is going to come to all the OS that the ArcGIS Runtime currently supports. So I'm really happy to show you today a native application running on iOS. So I have a simple iPad here, and I'm just navigating around, and you can see the performance on an iPad. I can also just simply follow a bird around the French Pyrenees. But the ArcGIS Runtime doesn't only support iOS, it does also support Android. So once again, I'm really happy to show you for the first time a native application using 3D ArcGIS Runtime on my 2-year-old Android phone. So I'm still looking in the Pyrenees right now. Don't worry, there's not an earthquake in the Pyrenees, it's just me shaking. And trying to find where that bird was. I think I might have let it go a little bit too fast. But writing native application gives me the opportunity to use the sensor on my phone to actually direct the camera and that's on Android. So I just show you really quickly how you can program 3D native application today using the ArcGIS Runtime SDK for .NET, but also with Quartz, you'll be able to do that on computer, tablets, and phone for all the OS that the ArcGIS Runtime currently supports. Thank you.
Thank you, Adrien. So it just leaves me to kind of sum up the Quartz release and really tell you when you'll be able to get your hands on all of this technology. We're actually in beta already. At the end of last year, we released a beta on iOS and Android, and it really focused on connected workflows, working with the map and the layers within a map, but in a connected mode. Later this month, in a couple of weeks, we'll be releasing another beta for iOS and Android, and that has the disconnected workflows that you saw Will showing earlier this morning. It has support for vector tiles as well as the mobile map package. And at that point, the iOS and Android teams are heading to their first release of the Quartz technology. So before the user conference, late May, early June, we'll be releasing iOS and Android in final form. At the same time, we're going to be releasing the other APIs and SDKs in beta. And they'll have, in addition to the connected and disconnected workflows for working with maps, they'll also have support for working with 3D scenes programmatically. And then final will be in Q3 this year. And we'll be shipping all the functionality on all the APIs and the platforms in Q3. And then there'll be subsequent releases of new technology on top of the Quartz architecture over the coming months. So that was runtime Quartz native app development.